We turn our attention now to research infrastructure supporting research translation. This session is going to be moderated by someone that you know very well and is a very good friend of ICRI. He was, in fact, the organiser of ICRI 2022. It's my pleasure to welcome back to the stage Andrzej Hardil.
Hello, good morning. You know me. The topic of today is research translation. And we took a broad view of that topic. It's not just translation to industry, to the markets, but in a wider sense, also to policymaking, but not only to policymaking. And we have a great three panelists, and the session will look like a bit differently, because I asked them, I squeezed them, please prepare just a handful of slides, 5 minutes each. And 5 minutes. And 1 or 2 slides to present your infrastructure, and then present one case study in translation that we are proud of. And we have France, we have Canada, we have Australia. And after the presentation, I would like to open the floor for a couple of questions from the audience. So the orange t-shirts, get ready. And I also changed the order of the speakers, so I hope I will not surprise the technicians too much. But the aim was to present a diverse, view, not only in terms of geography, and you can understand that, like the previous session, we are missing somebody from Latin America, Africa, or Asia. So it would be nice if, let's say, representatives of those regions could speak up as well, maybe comment or give a question. So get ready for that. And we actually have different domains represented. We have Ed Mitchell, who is gonna to be the first speaker from ESRF, from the synchrotron family. Then we have Michelle Hoepel from Australia, from the ocean observation, marine observation. And we have also Claire Brown from Canada, from Imaging Canada, distributed facility, distributed research infrastructure. So have the big players, the synchrotrons, we have the small players, the individual imaging labs that can be basically at every university. So you can see some diversity, what can be done in terms of research translation. So hopefully you will enjoy the session. I have also a couple of my own questions, so if there's still time, I will ask them. But it will be mainly to the audience, and I would like Ed to take the stage and present ESRF shortly, and then give us the case study.
Thank you for the introduction. It's a pleasure to be here. First time in Australia, and it is a long, long way away. That was a long trip. We arrived at the airport. There was no queue at immigration. Right? Pucker, really, really good. But there were the electronic gates, right? So I'm a British passport holder, so you go through the electronic gate, no stamp in the passport. Not good. So I asked the immigration guy, I said, can I get a stamp? I've traveled halfway around the world. I would really like a stamp, please. And he said, go over and see that lady over there, and she'll give you a stamp. And she did. It was really nice. She was very pleasant about it, and I have in my passport. Anyway, you don't care. That's my stuff, right? Anyway, now look, I'm Ed. I work at the European Synchrotron down here in Grenoble, and it's a pleasure to work there. Is it going to work? Yay! Okay. The video is relevant. Just wait, it'll get there in a second. So I work at the European Synchrotron, where we have 20 partner countries. There you go, right? So every now and then the Tour de France comes in front of our gates, and we get fantastic video footage from France television. And if you could hear the commentary in the background in French, they're saying, but the ESRF's wonderful, solving world problems, loads of science, all this stuff going on. But it's a great footage. I live just somewhere behind there in the mountains. We are funded by 20 countries, including Russia. At the moment, all of the work with Russia is suspended. No users, no collaborations, no purchases, no nothing. We have about 7 publications a day coming out from results obtained at the ISRF. We have lots of users, we've got lots of labs. I'm going to talk about a little bit about translation today in the 3 minutes that are left. We try to develop an ecosystem around the synchrotron to partner with, because there's no way in the BizDev office that we can go and work with 20 countries on our own. So we rely on intermediaries and multipliers to go and help us do that. So one of the example I'm going to use today is working with an RTO. In this case, it's the Fraunhofer and others, where we've been working on batteries. Of course, as a light source, we do all sorts of science, whether it's academic or commercial, industrial, technology transfer, or whatever it might be. But the most important thing is that we can do work on real samples. You take a real object, you put it on the beamline, you take the X-rays, and you can look through it. You can see what's going on inside. And this is the work we did with batteries. This is a partnership with Fraunhofer in Germany, the National Renewable Lab in the US, UCL over and the Faraday Institution in the UK, and NASA. And they've been coming over to the ISRF. They've developed a battery abuse chamber, right? Because we're nasty to batteries. And if you're nasty to a battery and it blows up, it's chucking all sorts of stuff out, and you really don't want that in the experimental hutch. So there's a safety-approved box. It's this thing there on the left-hand side, where you can put batteries into there. You stick a nail into it, short circuit. So this is a catastrophic failure of batteries. We're then looking at the battery using high-speed radiography, so megahertz speed, like this, and that's the thing you can see going on the film. So there's a nail puncher test experiment, right? It's a standard nail puncher going on. Inside the nail, there's a temperature sensor. The video's not going there very smoothly. That's slowed down, so in real time, it's taking a couple of seconds. The radiographer is watching what's going on inside the battery. This work has directly already led to better safety vents inside these batteries. So NASA's especially interested, because batteries in space, you don't want them to go wrong. You really don't want that. Although we're a research infrastructure, maybe some of you started hearing about technology infrastructures, which is all the rage in Europe. This is almost technology infrastructure in scale and what we're doing. It's a standard way of working. The nail test is a standard industry test, and we're developing products and helping people do things. It's less research, it's got more that kind of technology feel about it. We also provide this as a commercial A to Z service with Fraunhofer. So we provide the X-rays. Fraunhofer provide all the expertise in the battery work. So they provide this A to Z service. They buy the beam time from us, and then they provide the whole package to clients, which we can't talk about, but there's quite a few clients coming to use this stuff, which is very, very nice. It's so nice that in the US, NASA and Archer Aviation released a press release. They didn't tell us about this beforehand, so we're a bit surprised to see it, where they said, we're going to work with Archer Aviation because they want to make batteries and stuff like that. And they go up and say, in the little purple box, they say, we're going to tests will be performed using one of the most advanced high-speed X-ray facilities in the entire world. So they've seen this opportunity, and they're building up this collaboration to work with NASA and Archer Aviation to test batteries using the high-speed work of the ISRF. But that's not the only translation that's going on using this technology. Go on, go forwards. Oh. There we go, okay. The Renewable Energy Lab has also released the data they've collected as an open data source. So you can go and look at this. There's hundreds of these videos there. They're all got metadata. They're open for use. It's data collected either at the ISRF or Diamond Light Source in the UK. And this is the work of Donald Finnegan and the team over at the NREL. And he's had people coming up to him at conferences like this saying, thank you very much for doing that. He doesn't necessarily know who they are, because it's open. Anybody can go and use it. And he's very well aware that there are companies around the world, wherever they're from, that are using this data and getting hold of it and looking at what's going on inside batteries. So we hope to extend this work in the future. These are still modest-sized batteries, but we're doing work with commercial work on much larger batteries that you might imagine could be used in cars, which have a lot more power in them, and safety at the lab get a little bit more worried about that. But we're doing this kind of work there on these kinds of objects, either commercial work, translated into real products that you're using at the moment, and also into these open source information data banks. And I think, with a bit of luck, that was my 5 minutes. I think. Yeah. Thank you.
Thanks a lot, Ed. No, please. Come on the stage. And the second speaker is Michel Heupel local from Australia and Executive Director of Australia's Integrated Marine Observing System.
Good morning. It's a sincere pleasure to be here. Thank you for having me. Before I start, I just want to say that IMOS acknowledges and pays respects to the traditional owners of the land and sea on which our program operates and recognizes them as Australia's first marine scientists and ocean observers. Before I talk to you about how we're turning ocean observations into information, I want to, as Andre said, give you a quick introduction to what IMOS is as a program. We are a capability in the NCRIS program, which you've heard quite a lot about already this week. And we're a collaboration of 11 partners across Australia. So we incorporate all of the major marine science research institutions inside IMOS. We have really one singular goal, and that is to deliver benefits to Australia by delivering sustained ocean observations of our very vast and valuable marine estate. You can see here on the map, this is an indication of the scale and breadth of the observations that are brought into IMOS. So what do? We operate a range of capability around the nation. So everything from deep water moorings that are out in the Southern Ocean, Argo ocean profiling floats, ocean gliders. We use ships of opportunity, commercial ships to help collect data. We integrate satellite remote sensing. We have sensorized moorings. We use coastal wave buoys. And we even put the animals to work for us in IMOS. We track where animals are going and we fit them with sensors to help understand what the water quality conditions are where they're swimming. All of this data that's collected on these various platforms is made freely, openly, and available using FAIR principles through our data repository, the Australian Ocean Data Network. And this is how we can create the uptake and the use that we really want to get out of this program. So how are these data applied? In a range of different ways. If I start here, just a few of the examples. If I start up on the top left, ocean data are really critical in our weather and climate forecasting, particularly our long range, our seasonal weather forecasts are highly dependent on ocean data for their accuracy. On the other end of the spectrum, ocean data are really critical in understanding the path and the intensity of tropical storms. Ocean heat content is critical in those calculations. So we play a big role in both of those things. We also have a role in policy in helping understand what the conditions are, what the state and trends of places are, and which we should be establishing marine protected areas around to conserve them for the future. And then when we move over to the right-hand side of the slide, we're also engaging with more operational users, so helping support commercial fisheries by helping them understand the conditions in the water column, where they should fish to increase their efficiency, helping them understand implications of ocean acidification or harmful algal blooms on both live catch and also aquaculture fishing industries. And then finally, down on the bottom here, similarly helping support the Australian Navy collect environmental intelligence to inform their activities and their operations around the country. So those are some quick examples, but I want to drill in on one particular example just to demonstrate the value of ocean data more broadly. And this is a commercial shipping example. If you don't know, over 80% of the world's goods are transported on the sea. This is creating hundreds of millions of tons of CO2 emissions as we move things around the world. In fact, the International Maritime Organization has projected that CO2 emissions from shipping could go up as much as 250% by 2050. What I want you to look at is this map up on the top right-hand side of the slide. And what you'll see is the blue line on there is the traditional route that a vessel would take, the shortest port-to-port distance that they could travel. The purple line is an optimized route using the prevailing ocean conditions. What you'll see is that the purple line eventually catches up to the blue line and arrives at port at the same time. But what you don't see is that by taking that purple optimized route, the vessel has used 84 tons less of fuel by following the currents rather than steaming against them. That's a cost saving of about $50,000 US for that vessel, and it's reduced CO2 emissions by 250 tons. So we have a role to play in both increasing the efficiency and the activity of our industries, but also improving our environment through that information. So if I haven't convinced you by now that there's a lot of value in us having ocean observations, I want to leave you with this one piece. IMOS had a return on investment analysis done a couple years ago, with the economists determining that for every dollar invested in our program, there's almost $5 worth of benefit created for the nation. But it came with a caveat, and this is a quote from their report that I'm just going to read out to you. To a significant extent, some benefits from IMOS's activities and data cannot be quantified. Knowledge of the ocean is a public good, the immediate value of which to humanity is not always obvious or possible to quantify in dollar terms. And I will leave it there.
Thanks a lot, Michelle. And our next speaker is Claire Brown. I just mentioned 3 things about her because she comes from McGill University in Canada, where she's leading the optical imaging platform. But on top of that, she is also active in terms of the distributed small-scale facilities as president of the Canadian Network of Scientific Platforms. And I believe that is not just microscopy, but other fields as well. And she's also a Global Biolmaging Co-Chair, and she will explain what that is.
Great.
Thanks.
Thank you very much. It's a real pleasure to be here today and talk to you about a little bit of a different topic, the power of infrastructure platforms and networks. So as was mentioned, I'm a co-founder of the Canadian Network of Scientific Platforms, where we've brought together infrastructure platforms from across Canada. These are mostly funded by the Canada Foundation for Innovation with funding from provincial partners and corporate partners. And I think one of my main messages is that distributed infrastructure is major infrastructure. So you can see here we have a network of 238 platforms representing over $1 billion worth of infrastructure. And the idea here is to bring the community together around common challenges and work together to find solutions. And we really span all the way from engineering to health sciences. And you see some examples on the slide there of the type of platforms that we represent. So Canada Bioimaging is a technology node that is part of the Canadian Network of Scientific Platforms, and it's part of a larger network, Bioimaging North America, where we have over 1,800 members across Canada, the US, and Mexico, with a lot of industry and academic partners as well. And we have international members in the group. Bioimaging North America is then part of the larger Global Biomaging, which we've heard a little bit about throughout the week. And this group is really trying to bring together infrastructure networks around bioimaging and build the community and provide training opportunities, mobility, and really grow together as a community to bring advanced imaging tools to the community. So I'm going to give a couple examples of some things that are going on in these networks. So the first one was led by Canada Bioimaging, and was this idea of forming technology user groups focused around advanced technologies that the imaging scientists working in the platforms really need the expertise to bring these technologies to academic users, biotech companies. The facilities are already distributed where the research is happening and ready to implement, but they need to have that technology expertise. So this example is super resolution imaging, where in the top left, you can see a traditional diffraction limited image. And then in the bottom half of the image, you see what we can do with super resolution. And you can guess that going from that one situation to the other takes a lot of expertise in sample preparation, image acquisition, image analysis. And you can see in this example the 8 proteins that make up the nuclear pore complex in the nuclear membrane, and also the central transporter. And we're getting to the point now where we're at EM-like level resolution, and these technologies can be moved into living samples. So a second example is lattice light sheet, which is a high-resolution technique for imaging live samples. And this is a beautiful example of a T cell engulfing its target cell. And again, you can probably guess that just putting this microscope in your lab and bringing a sample, you may not get this quality of data. But if you have that well-trained researcher, that well-trained imaging scientist to work with you, then these things are possible. And by having those networks already established, we were able to build this group. We now have 235 members from 18 countries, and we're sharing protocols, procedures. Really importantly, we're sharing things that don't work well, so people are not wasting their time reinventing the wheel and struggling, but learning from their colleagues very quickly. So I'm going to give one second example, which will also bring a little bit of Latin America and Africa into the conversation. So we've started a Train the Trainer program, and this is really about capacity building and giving these imaging scientists the tools that they need to run their own courses and train their own communities. So rather than somebody traveling in and running a course every year, we can train the local people and give them the teaching resources, the hands-on activities, so that they can train their own communities. So the idea here is to make these technologies readily accessible across the globe. It's easily scalable to other technology areas and sectors, and it really empowers early career researchers. So the course has been run once in Canada, once in Argentina, and we're planning to run a third edition of the course in Australia in 2025. And the course has resulted in our trainees running courses in their own regions. So we've had instances of the course in Uruguay, which was run in Spanish, and in South Africa, which was run in English. And then next year, we have another course in Uruguay in Spanish, and there's going to be a course run in Montreal, Canada, in French. So in just 18 months, we've reached 13 countries, and we have 37 new trainers, with the plans to have the next edition here in Australia next year. And I just want to highlight two people to bring this back to the people who are doing the work. So Marcella went within less than a year from a trainee to a trainer, and now she has her own course that she's developed based on what she's learned in Spanish that she's going to be running now annually in Uruguay. And Naomi came and did the training course in Buenos Aires in June, and in September, she, in just a few months, was part of the faculty for the course that was run in Cape Town. So I think you can see here the potential that we can really ramp up the training capabilities across the globe and also really empower these young researchers. And I hope that we've given these imaging scientists a good image. So I'll just wrap up with a couple of comments, sorry. So I think these networks are really, they're ready. We've done a lot of work, it's ground up. We are really following open science, equity, diversity, inclusion, and we're ready to receive, biotech companies, academic researchers to use these advanced technologies for their research translation. And the networks themselves, though, need dedicated resources. And as has been said a couple times this week, we need a fraction of a percentage of the investment in the infrastructure for these networks so that we can coordinate, put people in touch with the right technologies they need, give the imaging scientists and the other technology trainers the tools they need to bring those technologies to their full potential. And it's a real call, I think, on national funders, because right now everything is being funded by philanthropy. And I think there's a tremendous opportunity to increase the return on investment with a relatively small investment in these networks. So thank you.
So many thanks, Claire. And now we have 20 minutes for discussion. And as I indicated, it's first on to you in the audience. If you might want to make a question or comment, feel free to do so, especially if you come from Asia or Africa or Latin America. You are encouraged. Over there, gentlemen.
Yeah, thank you very much. I'm Saud Sagala from the Resilience Development Initiative, RDI Indonesia. Thank you for the esteemed speakers and also very enlightening discussions. I wanted to connect, actually, because you're all bringing from your point of view, but maybe we also need to think from the global point of view. Take the word of climate change, the impacts, and how we can bring the issues. And many developing countries, including the global south like Indonesia, lacking the research infrastructures. But we need to also strengthen their capacity. So I like what Claire mentioned about the capacity buildings and so on. How we can leverage from what you showed here, increase the capacity, because otherwise we'll be facing the real problem, the impact of climate change, and it's going to be globally, whether you are from developing country, everywhere you will face it. So I think if we can hear about that, thank you, to leverage the research infrastructure to more other places. Thank you.
Yeah, thanks. I think it's on one hand about sort of research translation in terms of, creating another benefits to different community, but it's also very nicely links to the previous session about the global collaborations and how to be more inclusive and how to have really, let's say, all the regions of the world on board of the activities. Any other questions over there? Oh, sorry.
Thank you. Slava Lukin, the U.S. National Science Foundation. So I would postulate that one of the most important translational impacts of any research is trained workforce that goes into economy, into government, other things not to do with research, and they bring their technical expertise, they bring their critical thinking that are trained. Sometimes they're perceived as failures in the research community, which I think is wrong, but they really are, in most cases, the primary impact. The hardest part, and we face it as a funding agency in the US, is quantifying that. So the challenge, question to you and everybody, is how do we quantify that in some way so that we can then pass on that information to policymakers to explain what we're bringing to the society?
Yeah, let's collect one more question and then we will have a round of replies from the panel. Over there? Oh. Okay. Too many people in the room. Sorry.
Hi, Jacek Kronowski from the Victor Chang Cardiac Research Institute. I really think, Claire, you really made a very important comment that a lot of this work in collaboration, but also in actually moving things from output to impact, require acknowledging that for that we need experts and we need resources to do that. And we fund in research infrastructures large equipment for billions of dollars and also technical personnel to operate that, but not those positions or those sort of special things. And I wonder, this extends to me also to project managers, business developers that really can create impact out of what we do in the research infrastructure. So I wanted to ask you guys, all three of you, if you have found opportunities to actually fund those sort of positions through the funding you're receiving to really do that work. And second quick thing is, how do we identify early on the most impactful outputs from research that we can then turn into impact? I think this is very important to put in that process end users to help us identify this and then work on optimizing those things that are outputs to move them to impacts. So have you had the chance to engage end users in that process in your facilities? Thank you.
Yeah, thanks for all those questions. And now over Claire and the other members of the panel to reply.
So I think with the distributed networks, we really need the human resources to make those connections. And when I talk to my colleagues, I think sometimes they think a network is an email list and you tell everybody you're running a conference. So it takes a lot of work to pull these things together. The investment relative to the infrastructure is relatively small, but it does take work. And I think there's tremendous opportunity to bring the global community together around those networks. In terms of impact, we do have an impact working group with Global Bioimaging, and we're working on telling stories because I think, like today, the examples we see, we can really resonate with. And I think bringing the people behind those stories to the forefront is really important. And also finding ways to measure what we do. It is a distributed impact in these distributed networks, but there are ways that we can measure that away from traditional publications and grants. So I think we need to work with social scientists and really find ways to measure those things and bring them to the broader community and make show how these technical people are really a key part of the research success.
Yeah, there's a lot of thoughts going around my head at the moment with all three of those questions. I guess from an impact perspective, I think part of what we need to do is understand what we think our stakeholders and end users need. So going and talking to them and finding out what do they actually need from our programs. Having said that, we often also find people through making our data open, we find people using our data in ways we never would have predicted. So we have surfing apps that are popping up using the wave data that comes from IMOS. That's not an end user we would have predicted. So I think being open and being connected and trying to achieve what possible end users need helps us get that impact. But picking up the question about the globalization and how we connect, in the ocean space, that's where we operate. All of our oceans are connected. And having networks like the Global Ocean Observing System, where we have regional groups that are working to try and leverage off of each other and achieve more together and better understand at scale, is one of the ways that we can try and drive that. But it does require us to be connected. It requires us to be talking. It requires us to be open and be sharing and think about how we can create global equity in observing these places and making sure that everyone has access to the data. Because you're right, sea level rise is coming for every country that has a coastline. It's not just an Australian problem or just a European problem. It's something we should be working collectively to try and solve.
I think just going back to the question on, is that working? Yeah, probably. The question on training, it is indeed one of the main outputs. It's clear. A lot of the staff at Diamond in the UK, for example, have been trained at the ISRF and they've been recycled, that's not necessarily the right word, recycled back to their home country. But we also realize that we are producing a lot of PhD students. They're not all going to be group heads. They're not all going to be professors at the university. So we've recently been running a Marie Curie co-fund. It's called InnovaXN. It's just finishing. We had 40 kids on that. They're all PhD students using either the ISRF X-rays or the ILL neutrons. But the key feature was each of those had a company backing them up and was providing the R&D driver. So the work is still all publishable. It's not confidential. But they spent time with the company, so they got experience with a real environment. They got experience with us in a research infrastructure, and they often had an academic backer as well. So they're often working in an academic environment. Those kids are now going out and getting real jobs in the real world. And we did a little survey, a hands-up survey, and we said, in a meeting like this, how many of you want to go into industry? How many want to go into academia? How many want to do a startup? 80% of them saw their careers in industry, not in academia. Not in a research infrastructure, and a couple of people said, I'm going to do a startup. Which I felt was really encouraging. Now the challenge is, what's the value of them in the real world? We're very bad, back to you guys, we're very bad at tracking alumni. We don't know where they are, we don't know what they're doing, and maybe that's something we need to do better in the future.
Yeah, it's interesting hearing these insights because in the Czech Republic we are just about to launch a next assessment exercise, evaluation of research infrastructures. And one of the big elements will be also the socioeconomic impacts and transition to industry. And well, actually, in the policy field, the main focus is companies, companies, companies. But here what I hear, the message is, it's about, let's say, the impact on people, on the workforce, actually, which is going to translate from the infrastructure being highly skilled, going into highly skilled jobs in the industry and helping the economy grow with some sort of invisible path behind and traces to the research infrastructures. So I'm happy to open to another round of questions, but before doing so get ready with your questions. A question on the open data, because let's say when we speak about training people, open data is fine. When we speak about policy and informed policy making or climate change, open data is fine. But when we speak about companies using the infrastructures, what is it, let's say, about the open data? Is it a workable concept? Give us your insight, or maybe Michelle and Claire, then what's your take on that?
So in our facility, we have had several corporate users, and normally the protocols, procedures, and things we develop are open, and we openly share those. But normally the company has the data for themselves, and it's really up to them, depending on the application, whether that can be shared broadly. But I think having those conversations with the companies, like was mentioned, being with the right stakeholders to understand from them what information could be open and what information needs to be protected. And doing that with the global community, with groups like Global Bioimaging, I think is the way that we can find a good path forward to make things as open as possible.
Yeah, I think my response would be similar. The industries that we work with, they know that we make our data open, so it's kind of comes with the territory if they're working with us. But if they have something that's particularly sensitive, we can either, if it's time sensitive, then we can deliver those data in delayed mode, so we can hold on to them for a while and let that time pass and then make them available, or we can hold back, or they can hold back particular components that they might not want to be made openly available and give us the rest of the data. So I think it's about talking and working directly with them, which takes time and trust, but I think it's valuable to have those relationships and be able to take advantage of their data in our systems.
All of the data collected at the ISRAF coming in, like all of the light sources in the world, that comes in through the public program is published. It's part of the data policy. It's open. Anybody can use it. It's part of the rules. Whether you're an industrial or an academic applying for the access, the data is open after 3 years. Also, most of the light sources in the world, there's a commercial access. Data is confidential. We make the access as quick as we can, and usually it's based on a cost recovery price. But then the data is definitely not open. And yeah, we have clients, as you heard earlier, we can't talk about it. They buy the access. We're not allowed to release the data. We can't talk about the company name. And then making narratives and stories to tell to the stakeholders actually gets tricky, because the stakeholders also tell us, work with industry, do work with industry. We want you to do it. And our metric comes then down to how much money have you earned? Oh, this year it's about 5 million, which is good. It's nice, right? And they give us a target. There's an annual target at the ISRAF for commercial income, right? But that commercial income, there's always the tension then between the open access program and the commercial program. Because we do more commercial work, well, there's less available for the academic work. It's very modest what we're doing on the commercial side. It doesn't have a huge impact, but on some beamlines, we're using quite a lot of the beam time for the commercial work. With my hat on, I think that's a great thing, because we're having a direct impact in the real world on real ecosystems, and it's what our stakeholders want to see as well as the academic program.
Yeah. Okay, it's interesting to see that it's much more difficult to talk about the industry engagement, because actually you can't talk about that because of the confidentiality, and it might be much more easy to pick up, the sort of the training stories, the, open access impact, which at the end of the day, it's up to the taste of the policymakers, whether they want to hear that or whether they are stick to the idea, okay, what's the impact on the economy, strictly speaking. Okay. There's one more question over there, and I think there's one more. Okay, I think we can take up to 3 more questions. Please.
Okay. Thank you so much for the wonderful panel. I'm talking here on behalf of my capacity of Latin American, representing the European research infrastructure, and doing the international engagement for this organization. So my question is, how can we ensure that in all these initiatives that we have spoken about, we don't do it with other communities in a way that is patronizing, colonialistic? We go and teach them on how to do the things. We go and show them what is the best way that we do it. And to support that question, what are the mechanisms that we can also ensure that there is a two-way street of collaboration, that they can also come and show us how it's done, their learnings in open science? Because in Latin America, open science, I think we are one of the pioneerings, because we need to, because we don't have the resources to, pay science, pay nature. So that's my question. Thank you.
Yeah, thanks. I think we again collect the 3 questions and then we come back to the panel. So over there.
Hello, my name is Yuri Kolman. I come from Europe, but I will talk about Africa. I'm representing environmentally oriented research infrastructure dedicated to climate change and observatory of impacts of climate change. And we have nice long-term collaboration with Ghana, and we are providing them training and capacity building to be ready for implementation of Green Climate Fund and to reach the goals of Paris Climate Treaty, that you remember maybe that in Baku was agreed that there will be $300 billion US annually to be invested to global south countries, and you can imagine that capacity building is needed, and also involvement of various research infrastructures. And now the question is how we can manage that We didn't invest a lot of money, and we didn't have no Marie Curie grant, but we managed to have pool of nice postdoc graduates from Ghana. And it was very easy. Like it was my previous colleague said that it's not about tutoring to give wise advices from West to Global South countries, but we really started with the discussion with the Ghanaian partners, what are their needs. Then we created who are the suitable colleagues, and these guys really came back to like alumni back to Ghana, and now they are from various fields of science, not only directly with environmental issues, our counterparts, and now we are preparing joint projects for Green Climate Fund for Ghana. And also, the Ghanaians were so motivated that they paid, the Ghanaian government paid it, their stay in Europe. So this is very stable and long-term because they are really motivated, and now we have a nice ecovariance research site in Ghana that is fully in hands of Ghanaian partners.
Yeah, well, maybe I missed the question.
Sorry. And so one of the KPIs, and then I will come back to my question, sorry. And one of the KPIs reacting also for an NSF colleague is new users of using from Global South countries the research infrastructure. So this would be the KPI that was raised about the training. Sorry for yeah, and the question is how to make these trainings and capacity building sustainable, you know.
Okay, good to have a question. And the last question goes there. Okay.
Okay, I'm Takanori Kiga from Japan. I'm now organizing animal facility network in Japan. So I especially ask you about the bioimaging network or something, bioimaging facility network. I believe that manufacturers like Twice or Nikon or something have quite strong power in your field. So I'm asking how to establish a collaborative partnership between such companies. Is that people are joining your initiative, or you something to help your activity, or something that you could establish some development of new technology or new equipment? How organized you are doing the relationship between equipment makers?
Yeah, thanks a lot. I thought we will have an industry session, but it seems that we are turning into a training and international collaboration, which is not a problem because I think all the topics are relevant. So over to the panel to answer those questions and maybe tell the policymakers what is needed.
Sure. So on the cooperation with industry, Global Bioimaging is doing a lot, so maybe I'll catch you at the coffee break since I know we're quite short on time. I think the keys for engagement with the Global South are mobility funding is absolutely essential. These people cannot travel to meetings without full funding for that. And a really nice story from our Train the Trainer in Latin America is we had researchers from Latin America and researchers from Africa. And the South-South connection between the African and Latin American researchers was just amazing to watch. I didn't even need to be there. And I think we need to find ways to foster more South-South connections. They understand working in a resource-limited setting, and they're able to connect through that challenge and find really creative solutions.
Yeah, I guess one of my comments will be, for those of you who have traveled to this part of the world for the first time, I think you're recognizing how difficult it can be for people in remote regions and developing countries to get to you to experience these things. So I think we all need to keep in mind that it is difficult and it's very expensive for people to be able to come in and access this training, even if you make it available. So thinking about how we do make it sustainable, how do we find ways to, make resources more broadly available to people. And I guess particularly to the question over in this corner, I think one of the things we need to do is not assume what people need in other places. It's about having the conversation. And in IMOS, we have a sister regional alliance in the Pacific Islands, and we're talking to them now about how we can work together And my first question was, what is it that you need that we could help you with? Not here are things that we can do for you, but what do you need so that we can then match make what they need with what resources we have in our program. And I think it's that being respectful about what's needed and then trying to help from there. Rather, it's a pull more than a push.
Maybe two quick things. On the industry cooperation, we've been gratuitously using some EC funding to deliver a tailored service, so matching the synchrotron to industry, not the other way around. A BASF approached us and said, we want to scan loads of X-ray powder samples. We can't do it at home. It's going to take bloody months to do that. They're using it for sort of like battery genomics, if you like. We designed a service from scratch. We can now scan tens of thousands of samples in a couple of hours. There's been a startup created because of that, providing an A to Z service. BASF delighted, and that's now operational, and they're using quite a lot of beam time, and that's now going to be duplicated at other light sources across Europe. On the international partnership and cooperation, further European funding, which is great, is helping us to try to establish SESAMI, which is the synchrotron in the Middle East, funded by a range of countries that, especially at the moment, really don't talk to each other. And we're trying to establish SESAMI also as a support and training center, back to the training thing again, for Africa. Egypt's already a partner in SESAMI. South Africa's a partner inside the ISRAF as well. We're trying to then engage and build the links between SESAMI and Africa. So more of it's a push and a pull. I think in that case, it's going in multiple directions. And a large part of it is building the capacity, the skill set, the understanding as to what a synchrotron can do. Because as you've heard, they're expensive beasts. They're not cheap to run, they're not cheap to build. And there's maybe even a longer term aim. Africa is the only continent in the world without a synchrotron source. Right? When we put up maps of where the synchrotrons is, there's a big hole. And there's also something called the African Light Source Foundation, which is trying, and it'll take some time yet, to get a light source built in Africa for Africa by Africa. But to do that, the user community needs to be built up, but also the technical skill set to build, run, and operate one of these things.
Thanks a lot. Just a couple of reflections at the end of the session from my perspective. I think one of the learning points here is that research translation, it's not just about industry, and we had a big discussion on that. Second learning point is the open data don't hamper the industry or translation relationships. It can foster them, it can improve them, and it's about discussing with the commercial partners, what are the terms, so both sides do understand what are the terms and conditions. If industry wants to use and make the data public, well, they are welcome, and it can be for free, maybe. If they want to keep everything confidential, they are happy to do so, but then they have to show their credit card and pay hard cash on the table. And last point, which has no connection with the translation, but it has connection with the previous session and also the session yesterday about how we can build global governance and funding. Actually, it seems to me that, let's say, the charity funding, as shown by example from Claire, is one step ahead from the policymakers. They help to achieve something, whereas the policymakers, the funding agencies, and we've heard it today, also, let's say, the Canadian example mentioned by CFI, the infrastructure can be anywhere, but it's us Canadians managing and taking the decisions. I think, let's say, if we want to build something globally, I think we have to step down from those positions, in my view, and be a bit more open-minded and build up the consensus. But it's my pure sort of learning point from a person from a university who has no influence on the policy. So many thanks to the speakers and also for your questions. Thank you.
Thank you, Andre. Thank you, speakers. Look, 1.5 very quick things from me before I release you for a bit of a break. If you have or have not, so that's everybody, thought about going to one of the side sessions this afternoon, I would encourage you to, if If you haven't, do think about it. If you have, think about it again. They're all in the app. It's not a secret. There is a session on global ecosystem research. There is a session, opportunities in the ASEAN region, particularly new opportunities in the ASEAN region. There's a session on future digital infrastructure. There's a session on the Alps down under, which is a Swiss-Australian connection. There's also a virtual session, and hello to all the people who are joining us in cyberspace. A virtual session on global ecosystem research. The reason I raise this with you now is that some of those sessions are here, some of them are not. Some of them require RSVPs, and some of them are tighter on spaces than others. So if you think you've already RSVP'd, check that and make sure you know where it is, because it might not be as easy as walking in from outside. Give yourself some planning around that. And if you haven't chosen to do one, I would encourage you to do so. There's just so much good material there, and if the conversations that are going on around these rooms are any guide, it'll be worth being there, and probably probably more focused, I would think, too. So you'll get really value for money, if I can put it that way. Value for time. Okay, we are about to go to morning tea. We're back in here at 11:15, and it's going to be life-changing. All right, have a good morning tea.